Dark Fireworks, presented by Science at NASA. Warning: the movies you are about to see might make you feel uncomfortably close to the Sun. On June 7, 2011, Earth-orbiting satellites detected a flash of X-rays coming from the western edge of the solar disk. Registering only M for medium on the Richter scale of solar flares, the blast at first appeared to be a run-of-the-mill eruption. That is, until researchers looked at the movies. "We've never seen anything like it," says Young, a solar physicist at Goddard Space Flight Center. Half of the Sun appeared to be blowing itself to bits. Video beamed to Earth by NASA's Solar Dynamics Observatory revealed one of the most dramatic explosions ever. In terms of raw power, this really was just a medium-sized eruption, says Young, but it had a uniquely dramatic appearance caused by all the inky-dark material falling back to the stellar surface. Solar physicist Angelos Forlidas of the Naval Research Lab calls it a case of dark fireworks. The blast was triggered by an unstable magnetic filament near the Sun's surface, he explains. That filament was loaded down with cool plasma, which exploded in a spray of dark blobs and streamers. The plasma blobs were as big as planets, many larger than Earth. They rose and fell ballistically, moving under the influence of the Sun's gravity like balls tossed in the air, exploding like bombs when they hit the stellar surface. Some blobs, however, were more like guided missiles. In the movies, we can see material grabbed by magnetic fields and funneled towards sunspot groups hundreds of thousands of kilometers away, notes Forlidas. SDO also detected a shadowy shockwave issuing from the blast site. The solar tsunami propagated more than halfway across the Sun, visibly shaking filaments and loops of magnetism en route. As remarkable as the June 7th eruption seems to be, Young believes it might not be so unusual. In fact, he says, it could be downright common. Before the sharp-eyed Solar Dynamics Observatory was launched in 2010, space-based telescopes observed the Sun with relatively slow cadences and/or limited fields of view. They could have easily missed the majesty of such an explosion, catching only a single off-center snapshot at the beginning or end of the blast to hint at what actually happened. Could more dark fireworks be in the offing? Says Young, I wouldn't be a bit surprised. For more close encounters with the Sun, please visit science.nasa.gov. Summer Meteor Shower, presented by Science at NASA. It's summer. School's out, campfires are crackling, marshmallows are roasting, and fireworks are exploding in the night sky. Those fireworks are the Perseid Meteor Shower. Starting in late July and continuing through mid-August, scores of meteoroids fly out of the constellation Perseus. They cross the starry Milky Way, bisecting the heavens with vivid streaks of green or yellow light. Fireworks indeed. The source of the display is Comet Swift-Tuttle. Every 133 years, the huge ball of dirty ice swings through the inner solar system and leaves behind a trail of dust and gravel. At the moment, Swift-Tuttle is far away, but its debris is nearby, littering the July and August part of Earth's orbit. When our planet passes through the debris zone, specks of comet stuff hit the atmosphere at 140,000 miles per hour and disintegrate in flashes of light. Swift-Tuttle's debris zone is so wide, Earth spends weeks inside it. In late July, when our planet first enters the outskirts, Perseid rates are low. A camper peering out the door of his or her tent for an hour might spy only a half a dozen shooting stars. That's a pretty show, but the real excitement takes place in August. On the mornings of August 11th through 13th, Earth will pass through the heart of the debris zone. During the dark hours before sunrise, meteor rates could soar to more than 100 per hour. August 11th, 12th, and 13th are the dates to plan your summer camping trip. There's just one problem: the moon. The moon is full on August 13th, so it will be glaring brightly just as the shower reaches its peak. Many of the fainter Perseids will be overwhelmed by the moonlight. This is not a disaster, however, because some Perseids are fireballs and they will have no trouble piercing the glare. The debris stream of Comet Swift-Tuttle consists mainly of very tiny meteoroids. These minuscule pieces of comet dust produce meteors of ordinary brightness, easily overwhelmed by the moon. Fortunately, the debris stream is also spiced with larger chunks, the size of golf balls, baseballs, and so on. When these bigger pieces hit the atmosphere, they turn into fireballs that you can see right through the moonlight. You might spot only a few during a long observing session, but even a single fireball can make your whole camping trip worthwhile, burning an indelible streak into your collection of good summer memories. Enjoy your summer and the Perseid Meteor Shower. For more summer science blockbusters, please visit science.nasa.gov. Sun-grazing comet amazes astronomers. Presented by Science at NASA. Note to comets: stay away from the sun. On July 5th, a fleet of NASA and European spacecraft watched what happened when an icy comet got a little too close. A sun-grazing comet swooped closer to the surface of the sun than we've ever seen before, says solar physicist Dean Pesnell of the Goddard Space Flight Center. And now, the solar system has one less dirty snowball. The Solar and Heliospheric Observatory saw it first, using an opaque disk to block the sun's glare. SOHO recorded the early stages of the comet's death. The comet grew a long, bright tail as icy material in its nucleus furiously vaporized in the face of intense solar heating. By the time it happened behind the sun-blocking disk, the comet had become one of the brightest of the SOHO era. Since SOHO was launched in 1996, the observatory has recorded more than 2,000 comets, says Carl Badams of the Naval Research Lab in Washington, D.C. I'd put this one in the top 10 of all time. NASA's twin stereo probes also monitored the comet's approach. With 3 points of view, SOHO plus Stereo A and Stereo B, researchers could get a good fix of the comet's orbit. It was definitely a Kreutz sungrazer, says Badams. Kreutz sungrazers are fragments from the breakup of a single giant comet many centuries ago. They get their name from 19th century German astronomer Heinrich Kreutz, who studied them in detail. Several Kreutz fragments pass by the sun and disintegrate every day. Most, measuring less than a few meters across, are too small to see. But occasionally, a big fragment like this one attracts attention. The best view of all came from NASA's Solar Dynamics Observatory, or SDO for short. The Kreutz debris stream happened to be passing right across the solar disk, as seen from SDO, notes Badams. That was fortuitous for sure. SDO's high-resolution cameras recorded the comet's passage through the sun's atmosphere, says Pesnell, the SDO project scientist. We were able to see the comet vaporize before our very eyes, the first time we have ever seen such a thing. Researchers are studying the video in detail to learn more about the doomed comet. How massive was it? What caused the comet to glow so brightly? In some parts of the movie, it appeared to be even brighter than the fiery sun behind it. And was the comet's tail actually wagging? Stay tuned for answers to these and other comet questions as the analysis continues. Updates can be found at science.nasa.gov. What lies inside Jupiter? Presented by Science at NASA. Ever since the invention of the telescope 400 years ago, astronomers have been studying Jupiter. Who could resist? It's such a big, bright target in the night sky. Just one problem. It's tough to get to the bottom of a planet that's permanently cloudy. For 4 long centuries, the gas giant's vast interior has remained hidden from view. NASA's Juno probe, scheduled to launch on August 5th, could change all of that. The goal of the mission is to answer the question, what lies inside Jupiter? Our knowledge of Jupiter is truly skin deep, says Scott Bolton of the Southwest Research Institute in San Antonio, Texas. Bolton is Juno's principal investigator. Even the Galileo probe, which dived into the clouds in 1995, penetrated no more than about 0.2% of Jupiter's radius. There are many basic things researchers would like to know, like how far down does the Great Red Spot go, and what is the exotic material that lies at Jupiter's core? Juno will improve the situation without actually diving into the clouds. Bolton explains how. Swooping as low as 5,000 kilometers above the cloud tops, Juno will spend a full year orbiting nearer to Jupiter than any previous spacecraft. The probe's flight path will cover all latitudes and longitudes, allowing us to fully map Jupiter's gravitational field and to figure out how the interior is structured. Jupiter's interior is a place of great interest. The planet is made primarily of hydrogen gas. Deep inside Jupiter, however, high temperatures and crushing pressures transform the gas into an exotic form of matter known as liquid metallic hydrogen. It is what it sounds like, a liquid form of hydrogen akin to the slippery mercury in an old-fashioned thermometer. Jupiter's powerful magnetic field almost certainly springs from the dynamo action inside this vast realm of electrically conducting fluid. Juno's magnetometers will precisely map Jupiter's magnetic field, says Bolton. This will tell us a great deal about Jupiter's inner magnetic dynamo, what it's made of, and how it works. Juno will also probe Jupiter's atmosphere using a set of microwave radiometers. Our sensors can measure the temperature and water content at depths where the pressure is 50 times greater than what the Galileo probe experienced, says Bolton. Researchers will use that information to understand the deep structure of the atmosphere and unravel some of the mysteries of Jupiter's monster storms. Finally, Juno will get a grand view of the most powerful northern lights in the solar system. Juno's polar orbit is ideal for studying Jupiter's auroras, explains Bolton. Unlike Earth, which lights up in response to solar activity, Jupiter makes its own auroras. They are really strong, and we don't fully understand how they are created. Juno's sensors might solve the mystery, a beautiful bonus. For updates about the Juno mission and more information about cloudy planets everywhere, please stay tuned to science.nasa.gov.